Okay, maybe I'm not quite ready. I'm almost ready. I have to pull up the quiz.
Oh, always with the normal probability athlete.
Okay, now I'm ready.
You there, Seth?
Yeah, I'm here.
Do you have the group quiz ready?
Yes, I do.
All right, I'll start on, let's see, number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of negative 1.358, round to 3 decimal places.
It's really simple, I feel like.
Yeah, that's why I was like, it gives you the z-score already.
It gives you the z-score and what you need to find. I have like 0.175 after you round.
Let's see.
Yep, that's what I have.
I was trying to get that applet up. Yeah. 0.358. Ready for question 4?
Yeah, I can read it. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observation, x, the distribution of the sample means, so mean x. This cannot be determined from the given information.
Distribution.
Okay, let's see. I always feel like they word some of the things really, really strangely.
Right. Let's see. So, yeah, so it's asking which is going to have a smaller standard deviation. And, like, so the standard deviation formula was the sigma thing divided by square root of the sample size. But I'm still not sure how we're supposed to know
Yeah.
I mean,
the distribution.
so like logically, I would think it would be the distribution of the sample, because like the distribution of all the individual observations, so like say all 9 observations, I think would be a larger standard deviation. But if you get the means, it's going to be closer together because you're getting averages.
Yeah. Because I mean, in the reading it says, let me find it. For the mean of draws, the random sample with mean u and standard deviation stated the following are true. The mean of the random variable y bar x is u. So I think that would mean the distribution of the sample means would be right.
Yeah, I think that would be my best guess too.
Okay. So we're ready for question 5?
Yeah.
Yeah.
Which of the following results implies that the spread of, how did they say that? Bar over X decreases as the sample size increases. So that's just the mean, right? Is it that is?
Yeah, that's
Sample
that
mean?
references the mean.
Okay. Sample size increases. Oh, okay. Well, let's.
I mean,
It's
the
either
only
the
thing I
sample-
wrote about that was like at the beginning when it was reviewing distributions, and it talked about the central limit theorem.
Okay, let me
Right.
double
It's
check.
becoming more normal.
Yeah.
The central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. So it's the law of large numbers.
Yeah. That makes sense.
Yeah, I agree. Are you ready for question 6?
Mm-hmm.
See, scores on the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So let's see here. So it'd just be 160 minus 150.8 over 8.8.
Yeah, because we're finding that.
Wouldn't it?
Wait, it's her score, right? 160 minus 150.8.
Yeah.
Wait. Yeah, but then wouldn't it be over the standard deviation? Wait, is it just over the standard deviation for that one? Sorry.
Yeah, because it already gives us the standard deviation instead of having to calculate that.
Okay. So when do you have to like divide the standard deviation by the sample size? I guess when there's a sample size, because there's not one here. Okay, sorry. Okay, so 9.2.
What did you get for 6?
1.045.
Okay, so 1.05 or 3 decimals. Yeah, that's what I got.
1.045.
Yeah.
Yeah.
Okay, awesome.
Yeah.
Difference.
Let's see. Are we ready for 7 or still working on 6?
Yeah, I'm ready.
Now I'm ready.
Okay. What is the probability that a randomly selected student will score above a 160 on the quantitative portion of the GRE? Okay, probability.
So we just plug in the z-score and then look at the area above it and find out the probability.
So the 1.045 for the z-score, and then is that and the area above it would be the answer.
Right. Yeah.
We have it, so like
Could be.
0.148.
Yeah. Mm-hmm. That's what I got.
Yeah. Cool.
I was making this way more complicated when I was trying to figure it out.
I know. So you're ready for question 8?
I think so.
Yes.
So a random sample of 5 students was selected to take the GRE. Their scores are as follows. What is the z-score corresponding to the sample mean of those students?
So we need to figure out the sample mean first, right?
Mm-hmm.
And then figure out the score.
So I think, Heather, this is where we have to do the square root and dividing by and everything. Right.
Okay. So the average is a 160 again.
Yeah.
You guys are faster than me.
Well, I have a problem where I can never remember what math term means, so I always have to look it up. So I was like, I know mean is average, but I still have to look it up every single time.
Okay. All right. I got 162 for the mean. 160. I mean, so.
Don't we already have the z-score for it though, don't we? Since that was the average for question 3, or the z-score for question 3, wouldn't that just be the same z-score?
I think when there's a sample, you have to like change the formula a little.
Oh yeah.
Like, so it would be like 160 minus 150.8. So that's like 9.2 over, and it would be 8. Wait, would it? No, I don't know what I'm looking at.
The only thing I can't figure out is what is the value? Because, yeah, so that means 160, so it's like something minus 160 divided by something divided by the square root of 5, because there's 5.
Well, wait, yeah, square root of 5. 5?
Come on, I took lots of notes. I'm gonna look them up.
Oh yeah, because we have the standard deviation and the 150.8, which we still use for this one.
Okay.
So divided by.
Oh, right, yeah, we already have the standard deviation given. Oh, wait, so it should be 8.8 over square root of 5, but what something minus 160. Are you guys following?
150.8.
150.8?
It's 160.
Yeah, it's
Yeah.
160 minus 150.8 over divided by 3 divided by the square root of 5.
Wait, 3? Where's the 3 come from?
Or, I mean the 8.8.
8.8. Okay. Over
I was looking at the
the-
example and
Yeah, 8.8, but
Okay.
but what is it? 150.8 minus 160 or 160 minus
160.
Yeah, so it's 160 minus 150.8, right? Because
Yeah.
yeah.
Okay, so
I gotta find.
That can't be right.
So for the z-score, I get 3.93548.
I'm almost there.
Mommy, hi, mommy. Hey, mommy.
I got
Oh wait, no.
2.338.
Hold on. Sorry, I missed a step. Okay.
I did do that.
Oh,
I got
Shoot.
2.57.
Ugh. Okay, wait a second. Let's go through it step by step.
Yeah.
So 160 minus 150.8 is 9.2.
Right.
Then the square root of 5 is like 2.236 and such on.
Yes.
Uh-huh.
And then 8.8, which is the standard deviation, right?
Yeah.
8.8 divided by the answer for the square root is 0.9354.
What? Oh, I got 3.5778.
Oh.
It just maybe because I'm using the computer's calculator. I don't know.
Yeah. I'm using
Are you
it.
guys using also like keeping all of the decimal points through the whole thing because we're not supposed to reduce until we get our final answer?
Yeah, I'm using Excel, so it carries them all the way through.
Okay, I'm using Excel too. Okay, awesome.
Okay.
So 8.8
So
divided
that'd
by the 2.2360 and so on gives you 3.935. And then
Wait.
9. What was that other?
Okay. You said which? Sorry, I'm just confused at what step you're on now.
So I just divided. So I took the standard deviation and divided it by the square root of 5.
So 8.8 divided by
23607.
So why did I get 236,068?
Wait, for which one?
The square root of 5.
Yeah, I get 2.23607. I don't know if I keep
Oh.
expanding.
Oh, so that's rounded, I guess, because mine came out. Did you do
Well,
that in Excel too? The square root of 5?
Yeah, I did the square root of 5 in Excel, which keeps all the decimals.
Huh. Because mine in Excel comes to 2.236068.
Yeah,
Instead
I didn't have all the decimal points out, but I mean it carries through.
Okay.
So then for the 8.8 divided by the square root, I get 3.93548 for my first
Yeah, that's what I got there.
5 decimal points.
Okay.
And then dividing the 9.2 by the 3.93548, I get 2.33771. So 2.338 would be the rounded answer.
Okay. Okie dokie. I'm following now. Sorry.
No, it's fine. I'd rather be able to explain how I got to an answer than just kind of be like, yeah, I got it.
2.338 once we round. Okay.
Dylan's still back there. I ain't got a clue.
Yeah. Wait. How do you do square root in Excel? Because when I was doing on the,
So,
I was having a round.
so you'll equals SQRT open parentheses.
Okay. Yeah, I got the same thing. Sorry.
I just loved how at the start we all got completely different answers.
Yeah.
My z-score is 7.
So yeah, it's 2.33. Wait, we'll come back to the number. We're on question 8.
Mm-hmm.
Were we running the 3 decimal places?
Yeah, that's a 2.338.
Yeah. Okay. All right, we're all on the same page now.
Mm-hmm.
Ready for question 9?
Yep.
What's the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So a greater than a 160.
So we put that in the 2.338 is the z-score again, right?
Wait, is it 2.338 or 2.388?
338.
Yeah. Okay. For some reason, I typed it in wrong.
So we put that in the z-score, right? And then the number at the top that's only the area to the right is the probability, right?
Yeah. So
Yeah.
it's 0.0097.
So point
0.01.
right?
What was that?
0.010 after you round.
Wait,
Okay,
actually,
you guys just broke up for me. I couldn't hear a thing.
Oh.
So did we get 0.01?
Yeah, I got 0.01 after you round.
Okay.
Well, it says round to 4 decimal places.
Oh, does it say 4? Man.
Oh,
So it's 0.0097.
okay.
Just when we think we had the rounding figured out.
Yeah, it changes up on question 9. I don't know. We're ready for question 10.
Mm-hmm.
Okay, I'll read it. Oh, jeez. Hi. Okay. What is the shape of the sampling distribution of the random variable, which represents the sample mean of the 81 students who are selected?
Okay. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is less skewed. A random sample of 81 students will be drawn. Okay.
Oh, sorry.
Well, I was trying to figure out how to
My
the
bad.
skewed.
So we shouldn't have to do any math, right? Because it's a high sample size. It's
Approximately normal, right?
yeah, that's what I would assume. Because it says approximately, not completely normal.
Yeah.
Ready for question 11?
Yeah, I can read it.
Sorry.
What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? Round your answer to 1 decimal point.
Sorry, my daughter is being annoying. Question 10, did we get approximately normal?
Yeah.
Yeah, we did.
Thanks. Okay.
So is question 11 asking for the z-score? I'm confused.
The distribution of sample means.
Oh, but I mean, they give us the average and the z-score, but they don't give us the value to be able to solve the problem.
I think the
Oh,
sample.
they don't give us the value, so we replace the value with x and put in the z-score and then calculate it that way. right?
Uh, all possible samples.
Yeah, this one's confusing me. I mean, 11.
So the sampling distribution is the z-score, but I don't understand for all possible samples
Yeah, that's
what that means.
That's it, Mom. That's it, Mom. And then, Mom, that's it. This,
Standard deviation.
that's it, Mom. Look, that's it, Mom. Look at See, Mom. See, Mom.
Okay.
Do you feel like we're just missing something?
So I think I figured out the equation that we need to use with this. Set it up like so. I think what we have to do is find the value. Wait, but so do we have the z-score?
No.
He said no, we don't. So wait, let's see. Hold on.
We have um, the average GPA, the standard deviation, and the sample size.
So we're missing the value and the z-score.
Yeah.
Trying to figure out how to, and what we're trying to find is the mean, but it gives us.
Okay. So we have.
See if we can find an example like this.
Yeah, that's what I was thinking. I don't remember an example like this in the homework.
And I didn't see one. Okay.
Okay. Be careful.
I don't even know. Like,
I'm completely lost.
0.7. What's it asking for?
Would it for the mean of like I almost think that it's asking for like if you take a sample of this many students, like just saying that this is a large sample, so what will the mean be? Is that what it's asking? Like, is it just 3.5? Because the next question just asks for the standard deviation of the distribution sample. Like, so you know those like questions where we have to figure out the mean, the standard deviation, and then the shape. I think that's what this is, just in 3 different parts.
That's
Maybe.
when you said that, like, I read it differently, and that makes a ton of sense.
But all.
Yeah.
Oh my gosh, I'm gonna go like hit my head against the wall now.
Yeah, it's like that problem.
It just sounds way more confusing than
ABCD
that.
and just finding the same. Yeah, it's just 81, right?
Wait,
3.
the mean distribution, so it'd be 3.5.
3.5.
Question 11, 3.5.
Yeah, 3.5.
Now we're looking at the probability for 13. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Oh, did we do 12?
No, what about 12? Yeah.
12 was just the standard deviation. Oh, but it wants it to 3 decimal points?
Well, it's a distribution of the sample. I mean, so don't we have to figure out what the standard deviation is when you have a sample of 81? Or is it?
Oh, yeah.
So this is like review of last.
Yeah, so we take the...
So is this 0.7 divided by square root of 81?
I think so.
Oh, that should be... So yeah, that's the where you take the square root, right?
Yeah. Okay. Oops.
Yeah, so it should be 0.7 divided by 81, which gives you 0.778.
Is that wait square root of 81 or just 0.7 divided by 81?
Square root of 81, yeah. It's 0.7 divided by square root of 81.
So I got 0.078 after you round.
Yeah, that's what I got.
0.07.
Okay.
3 decimal places. Okay. The probability that the mean. Yeah. 13.
Oh, sorry. Go ahead.
No, I wasn't gonna read it. I was just gonna start. Okay, so at 13, we want the probability that the mean GPA for 81, for a sample of 81, will be less than 3.3. So we want to. Let's see, where's the less than?
Mommy.
Okay, so we need to figure out the z-score and then take it to the applet. So let's this one. So would we take 3.3 minus 3.5?
3.5, yeah. And then we'd use the 0.0777 repeating forever, I think, and take the negative 0.2 and divide it by that.
Okay. Oh. Okay. Deviation. And then do we have to take this, like, does the bottom half of this fraction need to be the standard deviation divided by the square root of the sample size?
Yeah. Yeah.
Okay. So square root of 1.
I get did Dylan, did you already get an answer?
Yeah. Negative
Negative.
2.571.
Yes. I'm always nervous that I'm gonna like screw the math up somehow.
But we're looking for probability, so now we plug that in.
What did you
Yeah.
get? Sorry.
Negative 2.571.
Okay, good. Okay. And then we put that in the applet
Mm-hmm.
and the less than side.
And it would be the middle, or is it just the bottom?
Just
just-
the left side.
Yeah, to the left of it.
0.005.
Yeah. Decimal places.
I am making faces because I was like, I did it wrong when I selected the first one. Oh, I like question 14. It's easy.
Sorry, I'm still a little behind. So 0.005 is what you guys got.
Yeah,
Yeah.
that's what we got.
Wait, that, like, logically, I don't know if I'm just overthinking it, but that doesn't make much sense. If the mean was 3.5, and they're saying what's the chance that someone got less than 3.3? How's it that small?
Shouldn't it be the area between the z-score and the left side? Because doesn't the right z-score side represent the 3.3?
Greater than 3.3.
Well, no, I think. Oh, never mind. I think I was just overthinking because the standard deviation is 0.7. It's really small.
Yeah.
Yeah. Because that's about 2.5 standard deviations away. So that makes sense.
Yeah, that does make sense.
I just think, I was overthinking it. For 14.
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? So isn't this just the right side then?
I think
Yeah,
so.
we had a lot of problems like that.
So it's the exact same, 0.005.
Yeah.
Okay.
Or wait, does this include the middle too?
Oh,
I think it's just the right.
I don't remember. One of them includes two sections though. Oh, it is the middle too. It is the middle too because the z-score that we got is the negative value. So that's saying that anything to the right of the negative z-score value is above a 3.3. It should be above a 3.3.
So we want to highlight the middle section and the section to the right.
Yes.
Okay, so it's 0.995.
I think that's what I remember from there.
Yeah, it's a little bit different because like in the practice problems, we switch the number, but this is still the same number. So yeah,
Yeah.
it includes a mill area. So the answer is 0.995, right?
Yeah.
0.99.
Uh,
Boy.
Ma,
Ready for 15?
Hold on just a second. Sorry.
No, that's fine. Don't worry about it.
Sorry. My 2-year-old daughter has stopped taking naps. This used to be nap time.
No. That's
Okay.
fine.
All right, last one.
Mama.
Okay, I'm ready whenever you guys are.
Okay. I can read it. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in the sample. Round your answer to 3 decimal points. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean as ours in the positive direction. Okay. So we have to start by finding the z-score.
So, sorry. Are we using like the sample mean or the? Because I've never seen before the sample mean is different. Right? Aren't they usually the same?
I'm using the sample mean because it gives us the 48 commercial passengers.
Then what are you using for the value?
The 185 pounds.
Oh,
Okay.
So I have 177.6 minus 185 divided by
Oh, I see. Okay.
26.7 divided by the square root of 48.
Okay. Wait 5 minutes and then I will help you.
Okay, lay down. Mama. Lay down.
Wait 5 minutes. You okay? Okay, did you guys get a z-score? I'm sure you did
Yeah.
because it take the longest. Okay, so I got negative 1.92018.
Yeah.
Okay.
Yeah. Same.
Yeah, that's what I got. So 1.920 for the z-score. And then we'd want the right and left side, but not the center, right?
Yeah.
At least that's what I understand from the question.
Mean. Sounds good to me. Is that...
Did y'all get an area?
I haven't put it in yet. I was just thinking,
Okay.
trying to at least. Let's see. So did you get 0.0549?
Yeah, that's what I got.
Oh, I didn't. What did I do wrong? Let's see here. Okay. The negative 1.92. Oh, it didn't like that. Okay.
Yeah, that makes sense.
Okay. 0.0549.
Yeah, so 0.055 would be the rounded answer.
0.055. Okay, I'll help you in just a minute. 0.055.
Are you ready to submit?
I'm as ready as I ever am for these quizzes. Admit. Always.
Okay, we were way more ready for the last quiz.
We just got one wrong.
Which one?
Question
I
got-
three.
I got 100.
Oh, I must have typed. Wait, how did I type in on question 3 at 0.358? What, did you put in something different?
Question 3, 0.175.
Wait, how did you? Completely different. Wait a second.
I thought we had agreed on 1.175. Because it gave us the z-score of 1.358.
I got one wrong.
And then it asked for that it's to the right and to the left of the z-scores.
To the right and to the left of them. Oh, okay. How did I get 0.358? I'm trying to remember.
You might have just looked at the, you might have accidentally typed in the last 3 digits of the z-score.
Oh, yeah. I think that's what I did. You said it was 0.158, right?
175.
175. Okay.
Oh, there's.
Yep.
Oh, yeah. They have the math for question 6. I'm so glad, Heather, that you were like, wait a second, guys, we're way over.
I know, it's nuts. Because it really did sound way more confusing than
Yeah. When you said that, I was like, I should go beat my head against the table or something. We're sitting here to get the math out.
At least it was all of us.
Oh. That
All
was
right. Well, see you guys on Monday then, I guess.
All right, yep. Thanks.
have fun with the homework quizzes.
All right.